next for me to introduce, wonderful, is Marius Löffler. Marius Löffler, you are an innovation manager at DIN. DIN is a German Institute for Standardization. And so you will be speaking about the role of standardization in quantum technology, and you will give us an overview of existing committees and participation opportunities, linking very well also with what we've seen just now. So Marius, welcome on stage. The floor is yours.
Great, thank you.
Yeah.
This one? Okay. So that is something everyone is think about when I talk about standardization. But standardization is not only about paper sizes and screws and bolts, and I mean, of course they are, because standardization is everywhere, and you can write down your letter on your standardized paper with your standardized format, and you put it in your standardized folder or in your standardized envelope, and even the envelope has a standardized little window where you can read the address through it. And I'm telling you this right now, sitting on a standardized chair. So, I mean, everything is standardized, right? And why? Because customers trust in standards, or they trust in standardized products. So it would be quite funny if this chair break. But we have not only standards for screws and bolts and paper sizes and envelopes and so on. We have also standards for some quite innovative topics like smart home, IT security, blockchain, AI, industry 4.1, 4.0, and even quantum technologies. But before I step more into the standardization of quantum technologies, some words about DIN. DIN is the German Institute for Standardization, and we are doing standards not only in Germany and also in European and international level. We are not a federal ministry, we are a private organization, and more than 36,000 experts are working with us to develop standards from the different fields of acoustic to water management and even quantum technologies. At DIN itself, we have 550 staff members and more than 3,000 core members. And here's, I guess, one of the main information. Standards are not falling from the heaven, and standards are not developed by DIN itself. Standards are developed by those experts that come to us and bring their expertise to start actual standardization projects. But before, let's step back. What is a standard? A standard basically is an agreement on how to do something in order to be able to repeat it with the same result. And this agreement is developed by experts of a consortium like you that has agreed on relevant requirements. And then they develop a paper where they determine characteristics, features, criteria, or attributes of products, services, processes, or systems. Quite right. But we have different principles we draft standards and standardization is about. And at first, standards are voluntary. That means it's voluntary that you develop standards and that you use standards. Standards are always public. We try to involve all of the different stakeholders. That means the academia, the industry, research institutions, consumer protection, environmental protection, etc. And standards are always developed with a consensus-based process. Standards always should reflect the state of the art, and standards should be coherent to each other. That means that they do not contradict each other, so that you have two standards on the same subject. And unlike laws, standards are not legally binding. They only become binding when they are stipulated in the contract or in a specific law. And we have indeed a lot of different standardization institutes, and those are, except for the three at the top, those are all the standardization institutes that are responsible for Europe. But no worry, we have 43 standardization bodies in 34 European countries. And for Germany, for example, we have DIN and DKA. DIN for regular standardization, DKE for the electrotechnical standardization. And as we have DIN in Germany, we have a DIN for France, for example. This is AFNOR. I do not know where AFNOR is. Over here. And so we have a standardization body or a national standardization body for each of the European countries. At the regional level or European level, we have the CEN, CENELEC, and ETSI. CEN for regular standardization, CENELEC for electrical standardization, and ETSI for telecommunication standardization. And the same applies also to the international level. And how does this work? Imagine that you are working in a company and or even at a research institute or at a university, and you go to your national standardization body. That means to me. And here you have the possibility to develop a national standard. That means for Germany, it's a DIN standard. Most common example is the DIN A4 paper size, which became later an ISO standard. And those national committee, or this national committee, can delegate you to either the European committee that develops an EN standard, or they can delegate you to, how can I step back? 1 second. Great. So they can send you to the international committee where you can develop an ISO standard. And that's the whole magic here. And then there are some different cooperations between ISO, CEN, and the national standardization bodies, and then we have different standards like DIN, EN, ISO, whatever. And another more important point is that I'm not only the national standards guy, I can also take my DIN hat off and take my CEN hat on, and then I'm able to preparing European standards, and the same applies also for ISO. So that means DIN is not only DIN, DIN is also CEN, and DIN is also ISO. So, and that is my key message, where I have this beautiful meme here. I want you to remember that I, as a DIN guy, do not develop any standards. You, as a community, develop the standards, and I do only the whole process, the boring bureaucratic process behind your current ideas. And that's all about the whole process stuff. Let's talk more about actual standards and committees and whatever. We have a lot of different standardization committees that focus on standards for quantum technologies. We have those mentioned here, DIN, ISO, IC, ITU, ETSI, CEN, CENELEC, and we have some companies outside that are making de facto standards that are not real standards, but you can count them as standards in a broader sense. And I want to mention some of them, not all of them, because the time is not enough for everything. At DIN, at the national level, we are elaborating right now the DIN spec 91480, which is on benchmarking of quantum computers, where we try to set up a standard to benchmark different quantum computing architectures. DIN spec is not a classical standard, it's more like an alternative way to the classical standardization process that can lead into actual standardization documents. And the idea is to develop a national standard on benchmarking of quantum computing and submit it to the responsible European or international committees. So then we have the ISO-IC, JTC. JTC is a joint technical committee. There we have the working group WG14 Quantum Computing. They renamed itself a few weeks ago. Now they are calling Quantum Information Technology. This group is led by China, and they have different work items or projects in their work program, for example, on the terminology and vocabulary of quantum computing and some quantum machine learning data sets and some general requirements also. Then we have ETSI. ETSI is the European Telecommunication Standardization Institute. They're not real European, but they're calling themselves European. That's another story. No, weird. Sorry. At first we have ISO IC, and there we have the JDC1 Subcommittee 27, Information Security, Cybersecurity, and Privacy Protection. And they developed 2 standards on the quantum key distribution. Part 1 is on the requirements, and part 2 is on the evaluation and the testing methods. Now we have this ETSI. And ETSI develops at different committees. For example, it's a quantum safe cryptography working group, standards or specifications, or group reports on QKD, quantum safe cryptography, signatures, public key encryption, and encapsulation. And we have the industry specification group on the bottom that develops group specifications and group reports on QKD. And this one is quite old. It was mentioned from Eric before, the Standardization focus group on quantum technologies at the European level, founded at mid-2020, active since, I guess it was beginning of this year or end of last year, and with around about 200 experts in over 30 meetings, we have developed this standardization roadmap document where we specified what are the most important topics that need to be standardized now in the future, and by whom they should standardize, by whom of those standardization bodies in this whole landscape. Then we have, I guess, the most recent or the most newest one, the Standardization JTC, again, a Joint Technical Committee 22 on Quantum Technologies, that had its kick-off meeting at the beginning of this year. And here we have 4 different working groups. Working group 1 is a strategic advisory group. Working group 2 is on quantum metrology and also on the quantum enabling technologies, like the basic technologies. Working group 3 is on quantum computing and simulation. And working group 4 is on quantum communication and quantum cryptography. And those have different work items in their current program. For example, we start to work on, they do not have numbers because they are quite new, and the numbers will assign to them accordingly soon. We first talk about quantum network best practice, the comparison of QKD and PQC. We are going to make a gap analysis of current quantum communication and cryptography standards. And we have the first European standard to be developed, of course, that focus on the characterization of quantum technologies, and there we have the metrics and terminology. And right now we have 4 additional work items that are in consultation, so maybe stay tuned or step in so that you can get more information on this. So, but why should you do this? I mentioned before, the most important thing is that customers trust your products, and customers trust your products, buy your products if they are standardized products. So standards can bring your solution to the market. Of course, they are transparent, they ensures the compatibility, defines interfaces, open up possibilities for you as your company. And I guess I'm ready. Sorry, that was too fast.
Oh, no worries. Thank you very much, Marius, for your talk. Excellent. I'm just thinking for a second if because we are a tiny bit in front of time, I don't know, would you be comfortable to answer one or two questions if there are questions? Because we have exactly, I think it's almost 5 minutes, so please feel free to go. Feel free to shout. I think I can also repeat the question if necessary.
So in quantum computing, we're currently only treating like toy problems, and a lot of the problems that will be industrially relevant will be relevant at a much larger scale. And while scaling up, usually the software stack architecture changes in many ways. So what would you say to the people that say you should not standardize now because the software stack is so volatile that it might change in a few years because of this scaling up and this unforeseeable changes in structure?
Yeah, we always have those discussions. This technology is not mature enough. We should wait with the standard when there's some more usual technology available. And as I mentioned, we do not write standards itself. We are elaborating a more pre-standard, like a technical report, a technical specification, which is a standard and light version that we want to start to write down something other people can refer to. So, of course, it's not the holy grail of quantum computing that we are elaborating right now, but we have to start anywhere.
Wonderful, thank you so much. There's another question from Michael. Please feel free to speak up. Yes.
Oh, sorry. I would directly connect to that question. So AI cloud did not start with standardization, right? But more like with adoption. Don't you fear if you start with standardization and let's say produce paperwork, that maybe big tech player just came in and said standards by himself, de facto standards by leveraging platforms or any kind of these kind of things. So I think we tend in Europe at least to waste is the wrong word. We spend a lot of time on standardization, but then maybe we are too late for the market.
So what is your question?
The question is, would it not make sense to start with implementing first and then do a deferred standardization? I think standardization is needed, but maybe, as you just said, to do something, but maybe working on the standardization bodies maybe would make more sense to have the experts in implementing and working together on implementation, not on writing papers.
I guess those are two different points. At first, standardization is always driven by the community, not by the Standardization Institute itself. And the second one, they are working on those projects, but they are also working on standardization in parallel. And of course, they are producing a lot of paperwork right now, but I guess it's important to that you can continue this whole, or that you can. We talked the last 2 days about the quantum ecosystem, and standardization is one of the key aspects of this quantum ecosystem in Europe.
All right, Marius, thank you again so much for your talk. Thank you also for being open to answer questions. I now have the pleasure to introduce our next speaker, and our next speaker is called Nikolaus Spethmann. Dr. Nikolaus Spethmann, you are the head of quantum technology, the Quantum Technology Competence Center, QTZ, at the Physikalisch-Technische Bundesanstalt. I don't know the English translation of that, but I'm sure you do, so please feel free to share that then. And so we've now seen a general overview about standardization activities by Marius, and so now, Nikolaus, you will go into specific needs, challenges, and strategies for developing standards for quantum computing. Last but not least, since this year, you are the vice chair of the Standardization Joint Technical Committee 22 Quantum Technology that we have seen before. Thank you again for being here, and the stage is yours.
Yeah, thank you very much. And I will try to continue exactly where Marius stopped with his presentation of the general structure of standardization. And I actually would like to answer your question that you had here in the front. So I'm very happy to discuss about this. And I will address in the very beginning the question if it's too early for standardization. But before doing that, maybe let me just say a few words where I come from and what we do have to do with quantum technology. So I'm from Physikalisch-Technische Bundesanstalt, and I would say, indeed, this is also not translated. So I'm not sure if I would translate Quantentechnologie Kompetenzzentrum, doesn't matter. So our main task is to provide the national measurement infrastructure in Germany on an international competitive level. So we are the National Metrology Institute. You could also say, in other words, we are responsible to define what a second is, what a meter is, and so on and so forth. So the question is, what does that mean, and what does it have to do with quantum physics and quantum technology? And for this, I brought this slide here. So if you want to create a machine that tells you what a second is, you need to build a machine that's obeying quantum physics, basically, to give you what a second is. So that is, in other words, quantum technology. And this is indeed what we do when we build up, research, and develop atomic clocks and define a second. So this technology, in some cases at least, is very strongly related to ion trapping, which is one of the possible base technologies for quantum computing. So as you can see, there's a very close connection here. And we have this expertise by definition at PT